Hello everyone. Today we'll be looking at a chemical engineering GATE question number 15 from GATE 2017. The composition of vapor entering a tray in a distillation column is 0.47. The average composition of the vapor leaving the tray is 0.52. All the compositions are expressed in the mole fractions of the more volatile component. The Murphy efficiency based on the vapor phase rounded off to the nearest integer is dash percent. This is a question from distillation part of mass transfer operations, and the reference NPTEL lecture series can be found in lecture 8 module 5 fractional distillation, subcooled reflex, tray efficiency and use of open steam, mass transfer operations 1 by Professor B. Mandal, Department of Chemical Engineering, IIT Guwahati. So let's take a balance for a tray in a distillation column. So let's take a tray and let's assume this is the nth tray in the distillation column. So there will be liquid and vapor incoming and outgoing in and from the column. So Ln minus 1 is the liquid that is entering the column, the tray. Ln is the liquid that is exiting the tray. Similarly, Vn plus 1 is the vapor that is entering the nth tray from n plus 1 tray, and Vn is the vapor exiting the nth tray. And their corresponding compositions can be Yn, Yn plus 1 for the vapor, Xn and Xn minus 1 for the liquids. Now, this is for a real stage or a real tray. Now, let's consider what is called as an ideal stage or an ideal tray. In an ideal tray, the products leaving the tray or the ideal stage will be in equilibrium. So, in such cases, in ideal stages, the compositions will be represented by X star and Y star. So this Yn will be Yn star and Xn will be Xn star for ideal stages. Now, Murphy efficiency. The definition of Murphy efficiency, we can say it as Murphy efficiency Em is equal to the ratio of change in the composition for a real stage or a real tray to the change in composition for an ideal stage or an ideal tray. Now, if you want to express it in terms of percentage, we can write it as into 100%. So here, change in composition for a real tray can be written as Yn minus Yn plus 1. This is in terms of the change in composition for vapor in the vapor phase. Now, similarly, the change in the vapor phase composition for an ideal stage, this can be written as Yn star minus Yn plus 1. So, Murphy efficiency Em is equal to Yn minus Yn plus 1 by Yn star minus Yn plus 1 into 100%. This is the equation for Murphy efficiency in terms of the change in composition in the vapor phase. Similarly, we can write the Murphy efficiency in terms of liquid compositions as Xn minus 1 minus Xn by Xn minus 1 minus Xn star into 100%. This is the equation for Murphy efficiency in terms of liquid composition. So here they have given us some data. Yn is 0.53, yn plus 1 is given as 0.47, and yn star is equal to 0.52. So we just have to substitute these values into the Murphy efficiency formula, and we'll get Murphy efficiency is equal to 0.53 minus 0.47 by 0.52 minus 0.47, which comes to 120%. Thank you.